All right, guys, we've been talking about exponential functions, and a huge part of exponential functions is calculating things that have to do with percentages. All things that have to do with percentages are exponential when you build them as a function. So it says a population of 800 beetles is growing each month at a rate of 5%. Write an equation that expresses that number of beetles at X time. So I introduced this formula today where I talked about P being the principal. It's also the y-intercept or the initial value, whatever you start with. And it really sounds like that started at 800. So 800 is my P value, if you will. And then it says I am growing at a rate of 5%. So growing makes me want to think about using the plus sign, because anything above 1 makes it grow, anything less than 1 makes it decay. So I want to do 1 plus 5% as a decimal. So let's divide that by 100 and get 0.05. Now, this is a formula for compound interest, and it works even if you're not using compounded interest. And there's no wording in here that says compounded monthly or daily or anything like that. So that means it's only once a year, and so that means my n is 1. And then it's also 1 times the number of years you have, and then for this one they're saying they want to use x, not t, which is fine. The variable can be whatever they want. And so if they want x, I may just make this y, like y equals something with x in it. So now the only thing I'm thinking about doing is simplifying it a little bit. Y equals 800. If you do 1 divided into 0.05, that's not going to change 0.05. And if you add those together, it's just 1.05. And then 1x can just be x. So here's an equation that will model how many beetles there will be based on a month or a year or whatever you want to do. Okay? So it says right here, about how many beetles will there be in 8 months. And so a lot of the problems we did in class, it was all about years, so I don't want that to screw anybody up. It says in the top, a population of 800 beetles is growing each month. So that is the idea of the time frame being set. We're talking about per month. So when you're talking about 8 months, that means that I can just say, well, X represents how many months there are. And so let's plug in 8 for the time. So you will need a calculator here. 800 times 1.05 raised to the 8th power. So it looks like there will be roughly 1,182 beetles. I want to round to the nearest whole number here because we're talking about population. We're talking about beetles here. So I don't want 0.9 or I don't even 0.0. I'm just going to say 1182. About 1182, and then why not write the unit? So that is about 1,182 beetles after 8 months. So we're going to try another one, and I may not do as much of this because this one is much more similar to what we did in class, but I will still lead us through a majority of it because it is slightly different. It says you invest $100,000 in an account with 3.5 interest, and then this one is different. They talk about compounded quarterly. And let's say you don't touch the money, you don't add any, you don't take any away. So what will that equation look like for so many future years? So it looks like we have 100,000, and we also have 1 plus, because it does suggest that you're investing, so it's going to earn interest, it's going to go up. And we want to divide this number by 100. Do never use the interest value as it sits. Always change that number by division. So that would be 0.035. And now for the n part, n is connected to this idea of compounded quarterly. If you think about quarters in a dollar, how many quarters are in a dollar? That'd be 4. So we're basically saying that this happens 4 times a year. So we want to divide this number by 4. And then we also want to do 4 times t, 4t. So this can be an equation that represents plugging in a time, and it'll calculate exactly what that would be worth after so many years. So I want you to go ahead and explore plugging in 10. And same thing for the next part. If you have a calculator, hopefully you do, and I want you to plug in 25. And so tomorrow we'll check to see how accurate you were with the calculator that you have at home in terms of calculating with that equation. Another thing we talked about was the idea of simplifying square roots that are not perfect. What I have at the very top, this blue line, at the very top we have all the perfect squares, and we need to use those perfect squares in order to simplify the non-perfect squares. So let's walk through at least two of them. If I'm thinking about 20, I want to think about numbers that multiply to be 20, but really I want to use special numbers. I want to use the numbers that are perfect squares, if I can find one. And they won't both be perfect squares, but I'm immediately thinking, okay, 20 times 1, 2 times 10, 5 times 4. Those are the things that come to mind as integers that multiply to be 20. Well, which of those uses a perfect square? 5 times 4. Now, you really want to understand that there's going to be a simplification step after we use these numbers. So that 4 I want to put first, because the square root of 4 is 2. And that allows me to just drop everything straight down. And now I have my answer in simplest form. We did not pick 2 and 10 because what's the square root of 2? What's the square root of 10? They're not integers, that's for sure. So that's why you want to pick numbers that do simplify to be an integer. Like 8. 8 is 4 times 2. Square root of 4, 2. So that would be 2 square root of 2. So I will give you a heads up on 22 and 24. Make sure you get the biggest perfect square. I'll do an example that's not on the paper. For example, the square root of 32. A lot of students wrongly think this is 4 times 8. Square root of 4 is 2, and they think they're done. But remember, 8 has a perfect square in it, 4 times 2. So that one is not done if you choose 4 and 8. If you choose 4 and 8, you need to now separate this again. Square root of 4 times the square root of 2, that'd be 8. Square root of 4 is 2. Those multiply to be 4 square root of 2. So how could we have done that quicker? Well, don't pick 4 times 8. Pick 16 times 2. And the square root of 16 is 4. So it takes you straight to the answer. So all I'm saying is when you do 48 and 72, make sure you are thinking about the largest perfect square that goes into that radicand value. Thank you so much. I hope you have learned from this video, and I will see you guys tomorrow.